Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about hydraulics. A very important concept when we're talking about hydraulics is Pascal's law. And Pascal's law states that pressure applied to an enclosed fluid is transmitted equally and undiminished throughout the fluid. This principle is put to good use in a number of different ways: hydraulic brakes on a vehicle, hydraulic hoists, hydraulic jacks, hydraulic presses, a number of ways that we can increase the mechanical advantage, or in other words, increase the force that is moved or carried. So if we take a look at a simplified drawing of a hydraulic system, the idea is that you have a small input and you create a pressure at that input by applying a force. Pressure is defined as force divided by area. So by introducing a force over some area, you create a pressure. That pressure is distributed equally and undiminished throughout this vessel at a right angle to the walls of the vessel. So at the output, we're going to have that same pressure, but the idea is we have a much larger area. And if we have a larger area, we can carry or exert a larger force. So that is the concept that we use in hydraulics. We have a smaller input and a larger output, introduce a force, and that will create a larger force at the output. Now, we can't create or destroy energy, and energy consists of force and distance. So although we can create a larger force at the output, it won't go as great of a distance as the force at the input. So you have to realize that there's a trade-off. What we gain in one area, we lose in the other. Let's take a look at an example. So we have a hydraulic system here where the input has a diameter of 2 inches, the output has a diameter of 20 inches. We're introducing a force of 30 pounds at the input, and we're asked to find the force at the output. There are 3 ways we can approach this question, and I'm going to actually do it all 3 methods, because I think that all of the methods have their place depending on what information is given in a question and what information is asked for in a hydraulics question. So not all questions are going to look identical to this one. So if I do this question with all 3 methods, you should be able to handle any type of hydraulics question. So the first way I'm going to solve this particular problem is using the pressure definition. Pressure is defined as force in pounds divided by the area in square inches, and that gives me pressure in pounds per square inch. We're talking about areas of circles, so remember that the area of a circle is pi, which is 3.14 or 3.1416, or there's a more accurate pi value on your calculator. If we take that number and multiply by the radius squared, that would give the area of a circle. What we're going to do first is find the pressure that's created by applying 30 pounds of force over this area. I need to find that area, but I can do that in my calculation. So I'm going to find pressure by taking 30 pounds and dividing by pi times, if the diameter is 2 inches, the radius will be 1 inch. So the pressure will be 30 pounds divided by 3.1416 square inches, depending where you round off. When I calculate this, I'll actually use the pi value on my calculator, so it might be slightly different than if you do it and use this value of pi. And we get 9.55 pounds per square inch. So that means we have a pressure of 9.55 pounds per square inch throughout the fluid, which means we have a pressure here of 9.55 pounds per square inch acting on the output cylinder. Now we want to find the force at the output cylinder. So again, we're going to use a definition of pressure. Pressure is equal to force divided by area. I want to solve for force because I know pressure, and I'm going to be able to calculate area. So I want to isolate force. And the way I do that is I multiply both sides by area. So force will be equal to pressure times area. I just multiply this side by the area and this side by the area. Cancels on this side, so force is equal to pressure times area. So my pressure is 9.55 pounds per square inch. We multiply that by the number of square inches that we have. If our diameter is 20 inches, the radius is 10 inches, so the area will be pi times 10 squared square inches. That will be 314.16 square inches. If I round off. Now if I use the value on my calculator instead of this number, because I've rounded this number off to show you, but if I use the value on my calculator and I multiply by my area, I should get exactly 3,000 pounds. So we've taken a 30-pound input force and we've been able to transform it through the hydraulic system to a force of 3,000 pounds. So if you're interested in knowing what the pressure of the system is, you could use this method to solve this. However, there are a couple of other methods and you might prefer those. So let's take a look at the next one. The second method involves the concept of direct proportion. Because the pressure remains equal and undiminished in all directions, that means the ratio of force over area remains equal and undiminished in all directions. So if I take my input force, which I'll use a small f, divided by the input area, I'll use a small area, that will give me the pressure. And I know that pressure is going to be the same here as it is here. And I can define the pressure here as capital F over capital A. So it's a direct proportion. If we increase the area, we're able to increase the force. I plug in my values. I have 30 over an area of pi times 1 squared. That will equal a force I don't know over an area of pi times 10 squared. So you can either find the areas or work with the numbers like this. I'll write this with the areas in. So that's 30 over 3.1416 equals force over 314.16. I get 3,000. So I obtained the same force using this method as I did with the first method. This is probably quicker, but this one doesn't tell me what the pressure is. If you don't need to know the pressure, then you might prefer using this method. Now I'm picking fairly easy numbers for the diameters, but it doesn't really matter what the diameters are. You have a calculator that can do the hard work for you. I just think it's easier for you to see the relationships when I choose easier numbers. There's a third method you can use for finding this force, and it involves the concept of mechanical advantage. I often use this method more than the other methods because I find it the easiest, depending on what the diameters are. So let's take a look at the third option for solving this question. Mechanical advantage is defined as the ratio of the load to the effort, and that means output force to input force. That definition for mechanical advantage exists for all types of systems, not just a hydraulic system. Because we don't have the two forces, we can't find the mechanical advantage, but I can use the areas to find mechanical advantage, and once I know the mechanical advantage, then I can find my output force if I know my input force. In finding the mechanical advantage using the areas, I'm using the concept of direct proportion. I know that if I double the area, for example, I double the force that can be lifted. So the areas are directly proportional to the forces. Therefore, I can use my areas to define mechanical advantage in a hydraulic system. This definition is only going to be true with a hydraulic system, but I can find mechanical advantage in a hydraulic system using the ratio of the output area divided by the input area. So in my example, I can find mechanical advantage by taking the output area, which is pi times 10 squared, over the input area, which is pi times 1 squared. So you could actually find the areas and then find the ratio, or you can take a bit of a shortcut. Notice we have a factor of pi in the numerator and we have a factor of pi in the denominator. So really all we have to do is take the ratio of the radius squared in the output and the radius squared in the input. This gives me a mechanical advantage of 100 to 1. What that means is this hydraulic system can lift 100 times whatever the input force is. So I set up my definition. Mechanical advantage 100 to 1 equals the load, which is the output force, over the effort, which is 30 pounds. I cross multiply and you can see that the load or the output force is 3,000 pounds. Again, I get the same result, just a different approach. When you're doing hydraulic questions, you might see questions that ask for pressure, they might ask for mechanical advantage, they might ask for one of the forces. So understanding all of these three methods should have you covered for all of those types of questions.